Hi everybody, my name is Peter. Welcome to this YouTube tutorial. In this section we are going to look at the nature of science, basically the process of science, scientific methods. Before you do any science course or any science subject, this is one of the first topics that they usually go through so that they clear up some doubts or some misunderstandings that we usually have in this in some of the terms that we shall see in this section. Today's objectives, we shall look at the components of the scientific methods. Then we will distinguish between a theory and hypothesis and the law. Then the process of science. So the components of scientific methods are the same as the process of science. So we shall straight go to objective number 2, then 3. Then we will make a conclusion from this topic. So therefore, let us jump to the second objective to distinguish between a theory, an hypothesis, and a law. To begin with a hypothesis is like a tentative guess. A tentative guess or a mere guess or an educated guess about something. So after making an observation and gathering knowledge about a phenomenon, scientists usually use what we call inductive reasoning to formulate a possible explanation. For example, if someone observes the behavior of, let me say, college students, so they usually, let me say, sit somewhere and look at the way college students come to class, the way they live, the way they interact with each other at the campus and all that. So this scientist is trying to make an inductive reasoning so that he comes up with his hypothesis. So an hypothesis, remember we said it's a mere guess. So from that he may draw an hypothesis and say, I know the reason why students come late to school, because he has been observing students using what we call the inductive reasoning. So this inductive reasoning involves critical thinking. So he critically thinks and rules out some of the let me say the mere factors that won't really work out, and goes with the ones that he thinks are strong enough to back up his hypothesis. So from that, then he uses what we call the deductive reasoning. It involves logic and prediction of an outcome of the experiment. So after he has observed the students, then he makes his hypothesis and says, I know the reason why students come late to school. Then he states his hypothesis. Then he makes he carries out his experimental design experiment. And under the experiment, you must have an experimental design. How are you going to collect your data? So he uses a specific design for his data. He identifies the independent variable and the dependent variable. So the independent variable is the same as the experimental variable. It is the factor being tested, whereas the responding variable is the dependent variable, is the one that gives you the results. The dependent is the one which is being tested. So the reasons why students come to school, then the dependent variables are the reasons he will list out. So then after identifying this, and maybe if he has a control in his experiment, usually a control is, in scientists use controls so that they find out, so that they really make sure that their data, everything that they've collected, is not biased. From that, you collect your data. So in science, after the experiment, we collect data. So the data has to be analyzed. So we analyze the data, and we have two types of data. The first one is qualitative data and quantitative data. So the quantitative data is more about numericals, numbers, pie graphs, and just name it, as long as it involves numbers. Whereas the qualitative is all about descriptive, you describe. Then from that, they can draw a conclusion. So a conclusion from the experiment usually is not the last is not the last process of science, because the process is repetitive. So from the conclusion, a scientist might again go back and deduce a new hypothesis and again carries out another experiment after he has maybe his hypothesis was wrong, or maybe he didn't manipulate very well his data, his design. So usually this process of science is repetitive. It is not a one-way thing. So from this, one point to take home, one is that science is built on observations. We do not believe in fairy tales in science. We observe, and in science, observation does not only mean sight, but it means using all our five senses. See, whatever you hear, you touch, you feel, you taste, everything. We use that in science. So thank you very much for today's tutorial. Tune in next time as we introduce the human cell. Thank you. Bye for now.